Hi, in this video, I'm going to solve this problem. I don't know where it's from. This friend sent it to me. It's probably a competition problem, or it could be a homework problem in a number theory class. Prove that n to the fourth plus 64 is not prime for all integers n. Proving that an expression is not prime is generally easier than proving that it is prime. To prove that something is a prime, you have to prove that it's not divisible by anything. Other than 1 in itself. Whereas proving that it's not prime, you only need to find one way for it to be divisible by something. So that's generally easier. And generally, there are two approaches. Number one is you prove that the expression is divisible by some known prime. Usually by using modulo arithmetic and show that the expression is congruent to 0 modulo a known prime. The second approach is to take the expression and factor it out into two factors. Now, if you can prove that neither factor is equal to 1, then that is a factorization of the number, and therefore the number is composite and not prime. All right, so let's strategize on this. Let me do an example of working with modulo arithmetic. So, for example, we know that all squares are congruent to either 0 or 1 modulo 3. Here we're given n to the fourth, and n to the fourth is the square of n squared, so it's going to be either congruent to 0 or 1 modulo 3. Whereas 64 is 63 plus 1, so it's congruent to 1. And when you add them together, then you get either 1 or 2, which is the same as negative 1 modulo 3. So we've just shown that n fourth plus 64 is not going to be divisible by 3, which doesn't help, right? When we're trying to prove that something is not prime, we're looking for it to be congruent to 0 modulo something, not congruent to 1 and 2. So as you try a few of these, you probably realize that it's not getting anywhere. So let's go for the second method, and that is to try to factor n to the fourth plus 64. Well, 64 is 8 squared, so that means it's 2 to the 6th. So this one is of the form 10 n to the fourth plus 2 to the 6th. So it's probably not going to be very helpful working with fourth power because this one cannot be a fourth power of an integer. And sixth power or cubic doesn't help because that one, n to the fourth, cannot be a cube or sixth power. So it looks like we're going to work with this as if they are squares. So I'm work with this as n squared squared plus 8 squared. Well, it's a sum of square. Sum of square doesn't tell us anything. But difference of squares does. So we know that a squared minus b squared is equal to a minus b times a plus b. And while we're on the topic of squares, we also know the formula for square of a binomial. A plus b quantity squared is a squared plus 2ab plus b squared. And when it's a minus here, then it's the minus there. So we know these two formulas. Can we make this expression into one of these? Yes. When you see something like this, it's a standard trick. Okay, it's a standard trick in calculus, it's a standard trick in algebra, it's a standard trick in number theory. And that is, if you see something that's almost like a square of a binomial, you complete the square and see what happens. So right now, I have n squared plus 8 squared. So I'm going to complete the square using this formula by adding the 2ab term in here and then subtracting it back out. Plus 2 times a is n squared and b is 8, and then subtracting it back out. Then all of this becomes n squared plus 8 quantity squared minus, and then all of this is 16n squared. Oh, now I have a difference of squares. And if I have a difference of squares, I can factor them and I'm practically done. 16 squared is 4n quantity squared, so I can factor it out like that. And this is not prime unless one factor is equal to 1. So let's see if it could be 1. Can the first factor be 1? N squared, I'm going to rewrite it in order like this. Can this be equal to 1? Well, let's complete the square again. N squared minus 4n plus 4 plus 4, which is equal to n minus 2 squared plus 4. This is a square, so it's greater than or equal to 0. And I add 4 to it, so the whole thing is greater than or equal to 4. And if it's greater than or equal to 4, it cannot be equal to 1. How about the other one? It's n plus 2 quantity squared plus 4 is greater than 4, so it's not equal to 1. Since neither factor is equal to 1, the original expression is composite. There we go, QED. Hope you enjoyed it. I enjoyed it. Any questions or comments? Put it in the comments section below. Like, share, and subscribe for more contents. And thanks for watching. Bye.